Okay, so this is day 2, and hopefully it goes as smooth as day 1 does. So um, let us check out the problem. I need to figure out how this thing. So we're going to take a series of commands like forward 1, down 2 or up 3. Forward X increases horizontal position by X units. Down X increases the depth by X units. Up X increases the depth by X units. Note that since you're on a submarine, down and up affect your depth. And so they have the opposite result of what you might expect. Okay, the submarine seems to have already a planned course. You should probably figure out where it's going. For example, your horizontal position and depth both start at 0. Steps above will then modify at 5. That's 5 to your depth. Forward 8, a horizontal position of 15 and a depth of 10. Multiplying these together produces 150. Calculate the horizontal position depth you'd have following the planned course. What do you get if you multiply your final horizontal position by your final depth? Okay, so seems good enough. Okay, so let's just put in this raw input and let's think about how to represent a command. I know in years past I've said I don't like data classes. I've given up that crusade. Now I use them even though name tuple is better. Class command hey, that's pretty good. I wonder if it's cheating again because apologize for the dog. Static method from string s. Look at that. Direction distance equals s dot split return command direction int dot distance. So the question is it cheating off of other people doing advent of code, or is this thing what I want to do that predictable? Data class okay. That's okay. Well, that's not right. Interesting. I have a horizontal position and a depth. So what do I want to call those? I will call those horizontal int and depth int. And I'm just going to modify this in place. If command direction equals forward, self.horizontal plus equals command.distance. So that's actually true. Otherwise, if command direction equals up, okay, that sounds good. Self.depth plus equals command.distance. Okay, here's where this is wrong, because in their instructions, they said down and up affect your depth. They have the opposite result of what you might expect. So down 5 adds 5 to your depth. So self.depth minus equals command.distance. L if command direction equals down. Okay, so it's smart enough to figure this out. So that's good. And then that's really interesting. So that seems right as well. Now what I want to do is I want to say commands equals alright, that seems pretty good too. And now I want to say position equals, okay, I'm really wondering if this is cheating. For command in commands, position.move command, okay? And then I want to assert that position.horizontal equals 10, and I want to assert that position.depth equals -5. Okay, so I don't think those are the right numbers to check, but so let's see. In this one, forward 582 is 15, and down 5, up 3, down 8 would be 10. So 15 and 10. Okay, so that's what I want. So position horizontal equals 15, position at depth equals 10. So it did the work for me, but it wrote the test cases wrong, same as it did yesterday. So let's see, if I do python day02.py, that test passes, so that's good. So let us get the puzzle input, which is this. And I need to add day 02.text. Paste that and save it. So now let's say if name equals main. Okay, no, that's not right. Raw equals open. Okay, it's actually data day02.text.read. Notice that I didn't use a with block. I'm too lazy to do that. And then commands equal command from string s for s in raw split lines. So that seems right. Again, that seems right for command and commands. Okay, that seems good. Position.move command. And that's not what I want to do. I want to do print position.horizontal times position.depth, because I think that's what they wanted me to do. They want me to final horizontal position by your final depth. Okay, so let us run it, and it says it is this large number. So let's try it. That's the right answer. Continue to part 2. Based on your calculations, the blank course doesn't seem to make any sense. You find the summary manual and discover that the process is actually slightly more complicated. In addition to horizontal position and depth, you also need to track a third value, aim, which also starts at 0. Commands also mean something entirely different than you first thought. Down x increases your aim by x units. Up x increases your aim by x units. Forward does 2 things, etc. Again, note that in your summary, and down and up do the opposite. Down means aiming in the positive direction. Now the other examples of blah 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 have a horizontal position and a depth. Because your aim is 0, your depth does not change. Down 5 adds 5 to your aim, resulting in a value of 5. Okay, so I think what I'm going to do is I'm just going to create a new data class, and I'll call it aim position. Nope. So aim is an int, and horizontal is an int. Actually, let me do it this way. Horizontal is an int, depth is an int, and aim is an int. And now let me go back and read this and make sure. You also need to track the value aim, which also starts at 0. So let me just put default values in for all these, so to make our life easier. Equals 0, depth int equals 0, aim int equals 0. Move self command. Okay. So these are wrong, but let's go figure out what the right thing is. Okay, down x increases your aim by x units. Okay, so down self dot aim plus equals command distance, and up is self dot aim minus equals command distance. And now if command direction equals forward, it increases your horizontal distance by x units and it increases your depth by your aim multiplied by x. So plus equals command.distance, self.depth plus equals command.distance times, hey, I got that right, self.aim. Okay, so I think that is good. So now let us try this again. Position equals, I'll call it aim position for command and command position dot move dot can. Okay, and now horizontal position is 15 and depth is 60. So let us, and depth is 60. All right, so let us try to run this and see if it works or if I screwed something up. Okay, so that worked good too. So now, using this new interpretation command to calculate the horizontal position depth, you have to function. Of course, what do you do if you multiply your final horizontal position by your final depth? So let's just try it again. Okay, that's right. That's right. That's right. That's right. Okay, so let us try this. That is the right answer. Good. Okay, so this one was a little bit more interesting in that, you know, again, Copilot did a lot of the work, right? So it's, but at the same time, it did a lot of it wrong, right? So the things it wanted to do for this move command were not right because it did not reverse the up and down the way that the instructions asked us to. So it wrote it differently. And then the aim position, it didn't get quite right at all, but that's because it was something simple. So you know, so this one is cool. Yeah, I'm much faster with the Copilot. I sort of didn't expect that, but definitely I am faster with the Copilot. So again, it's like, it's less cheating today. Today, you know, Copilot wrote the code that was boring, and I fixed it so that it did the right thing, right? So it's not like Copilot solved the problem. It wouldn't solve the problem. I solved the problem, but you know, it figured out what I was gonna do, and it's sort of like a, you know, half-brained helper, if you will, which is kind of neat. Yeah, I thought that was good. So anyway, that is all for today. You got to see me use data classes instead of name tuples. You got to see me do my kind of data modeling that I always do. You got to see me write little unit tests the way I always do, and yeah, it's a very Joel solution helped by Copilot. So that's it. Thanks for watching, and I will see you tomorrow. I think tomorrow's Friday. Yeah, I'll probably do it anyway. All right.